In this video, we will learn how to create tasks in FreeRTOS. Each task is a small program in its own. For example, reading data from a temperature sensor in a temperature control system. Creating a task. The tasks are created using the FreeRTOS xTaskCreate API function. So there are two things that we need to do. We have to create the task and then we have to implement the task. And the tasks are implemented using this function. So we have to create a function to implement the task. So we have to specify name of the function that implements the task. This is the xTaskCreate API function which is used to create the task. So it accepts different parameters. So first parameter is the name of the function that implements the task. And then the second parameter is the task name, descriptive name of the task. The third one is stack memory, stack depth. The fourth one is PV parameter. So it's an optional parameter, or if you are not passing any parameters, then you can set it to null. The next one is priority. We have to assign some priority to the task as per our application requirement. Then last one is task handle. So it's a pointer to handle the task. If you are not using task handle, then you can set it to null as well. So mainly these are four parameters: PV task code, name of the function that implements the task, task name, stack depth, and priority. And we can also pass some parameters. If we are not passing any parameters, then we can set it to null, and we can also use a task handle. So now we have to check whether that after executing the API function, we have to make sure the task is created. So for that, there are two return parameters that we need to check: PD pass and PD fail. If the task is created successfully, then it will return PD pass, and otherwise it will return PD fail. So if the return of the task is PD pass, then it is created successfully, otherwise it will return PD fail. Yep. Okay, now we'll take some examples, and we are going to use Atmega 16 microcontroller to implement the FreeRTOS task. So we have to create two LED blinking tasks for Atmega 16 MCU. So specifically we are using Atmega 16 MCU, but the same concept can also be applied to other microcontrollers as well. So this is the first task that we are going to create. So this is the name of the API function, xTaskCreate. Then this is the function name that will implement the task. T1 is the name of task. 8T is stack memory, and we are not passing any parameters, so it is set to null. And 1 is the priority of the task, and we are not using task handle, so again this parameter is also set to null. Similarly, we have to create task 2 or T2 using the xTaskCreate API function. Now we have to write two functions corresponding to task 1 and task 2. So here this is the function task 1. So we have to keep same name as specified in the TaskCreate API function. And here we are blinking LED at every 300 millisecond. Then this is the function for task 2, and this will blink the LED after 500 millisecond. So we are providing delay using vTaskDelay API function. So this API function is used to provide delay, and it's a inbuilt function in the FreeRTOS, and it accepts the number of ticks. And for this example, we are using 1 millisecond as a tick period. So this will provide 300 millisecond of time delay. And this function will provide 500 millisecond of time delay. If you change the tick clock, the delay will also get changed. So this is a complete program. We have to include some header files corresponding to FreeRTOS and AVR header files for ATmega16 MCU. And then we have to do some basic hardware configuration. So these two syntax will configure PA0 and PA1 in the output mode. And then we have to create two tasks using xTaskCreate API function. And then we have to start with scheduler using btask start scheduler.